Okay, this is a video just to describe some of the basics of right triangles. It's going to help us with just kind of the introductory stuff. Much of this is going to actually be a review from geometry. So we're going to move fairly quickly through the video. Again, feel free to pause at any point in order to take notes. One of the biggest things you're going to be doing with right triangles is if they give you two sides of a right triangle, so again, I've got to assume it's a right triangle, we're finding that third side. So again, a major review of the Pythagorean theorem. But in order to use angles on triangles and talk about sines and cosines and tangents in a minute, we're going to have to know about the sides. So again, the Pythagorean theorem is a squared plus b squared equals c squared. And depending on what information they give you, you can set it up differently. So for the blue triangle, over here at the left, first of all, we're going to say 4 squared plus 12 squared. The two legs of your triangle adjacent to the 90-degree angle are equal to your hypotenuse squared. So x squared on the right side. 4 squared is 16 plus 144 equals x squared, which means x squared equals 160. And the square root of 160 will be equal to x. So x will be equal to 12.649 according to our calculator. 12.649. Now, the one thing you want to be careful of is what information they give you. Again, 20 on the red triangle is our hypotenuse. It is opposite that 90-degree angle. Therefore, we're going to set it up a little bit differently. 15 is a leg, but so is x. So this time we're solving for one of the legs. So x squared will be equal to 400 minus our 15 squared, which is 225. And basically x squared will be equal to 175, so x will equal the square root of 175, which comes out approximately equal to 13.229. Again, just calculations off of our calculator. Remember to round to 3 decimal places in order to be reasonably accurate. Now, once we know how to deal with the side lengths of a triangle, again, a quick review of trig functions. So again, take a minute to record the notes that you see here. At the bottom, we're talking about sine, cosine, and tangent. Remember, they are ratios of the sides of a triangle. The easy way to remember sine, cosine, and tangent are using SOHCAHTOA. So stands for the sine is equal to the opposite over the hypotenuse. So the sine of theta on our triangle, the opposite is A, the side opposite the angle that we're looking at, theta, down here on our triangle. B is considered the adjacent. So when we're talking about the cosine, and we say that it's adjacent over hypotenuse, or ka in SOHCAHTOA, it will be B, the adjacent, divided by the hypotenuse. And lastly, tangent, again, is opposite over adjacent. So we just have to identify what 3 sides we're looking at. Again, that depends upon which angle we're looking at. And then you can decide which trig function to use depending on the situation. There are 3 other trig functions. They're all the reciprocal functions. The sine, its reciprocal is known as the cosecant, or CSC of theta. And again, if the sine is a over c, cosecant will be c over a. The cosine, its reciprocal is the secant, or SEC of theta. And finally, the tangent is the cotangent reciprocal. So you can kind of flip that over. If that was a over b, we can call it b over a. An easy way to remember which ones go together, or what helps for me anyway, is that the cos don't go together. So the cosine doesn't pair up with either the cosecant or the cotangent. It has to pair up with the secant. Tangent and cotangent go together, and therefore the sine and the cosecant are tied together. All 6 of those trig functions are helpful for you when you're setting up an evaluation problem or evaluating the 6 trigonometric functions of theta. First thing to realize is they gave us all 3 sides of our triangle. If any of them were missing, again, that's a great opportunity to use the Pythagorean theorem. But in that case, we can start off saying sine of theta, and don't forget your theta there, will be equal to, well, so in SOHCAHTOA. So where theta is right now, 12 will be our opposite, 5 is our adjacent, and 13 is our hypotenuse. Therefore, sine being opposite over hypotenuse is going to be 12/13. If we want to think about its reciprocal, remember sine and cosecant are reciprocals, so the cosecant will be 13/12. Next trig function of the big three, as I call them, cosine, which again is ka in SOHCAHTOA, so the adjacent, or 5/13. And again, we can quickly do its reciprocal, the secant, being 13/5. Lastly, we need to fill in the tangent, which remember from SOHCAHTOA is TOA, the opposite, 12 over the adjacent, 5. And its reciprocal, the cotangent, COT, of theta, which will be 5/12. Once we know how to evaluate or sort of set up those trig functions, we can use them on our triangles. So an opportunity here is to look at what do you know, what are you using in order to find the missing part. Our missing part here is the hypotenuse. We know the adjacent. If we know 62 degrees, the adjacent side is 6. So hypotenuse and adjacent, this is a great chance to use the cosine of 62 degrees. Cosine at 62 will be adjacent over hypotenuse. Realize we also could have used the secant. Remember, the secant of 62 degrees would just be the reciprocal of that. So x over 6, which is actually fairly easy to solve. We just multiply our 6 over to the other side. So we could also solve that instead. Now, if you have the TI Inspire calculator, this is a great chance to just type that in. Again, if you go on your TI Inspire calculator here, on your keypad, try to move it over here so we can try to see most of it there. There, we have adjusted the screen a little bit. But on your keypad, you'll just type in 6 divided by, oops, sorry, delete, 6 times, and then you get this nice trig button over here. So we can type trig, and remember that we are dealing with the secant, so we're going to say secant of 62. And now here's where you want to be careful. If you're in degree mode in your modes, remember, check under doc settings and document settings whether or not you're in degree mode or radian mode. If you're in degree mode, you can just type in 62 and hit enter. If, on the other hand, you were in radian mode, you'd want to be careful to put in your degree marker. So I can go down here to the pi button and press that degree marker and hit enter. And you'll notice we get 12.708. So when we go back to our main screen, we can now say that we were equal to 12.078, I believe was our correct answer. Oops, 708. Or 780 here. Let me fix that real quick. Now, another way to solve it again was using our cosine down here. We would just multiply our x over to this side. Think similar to rational functions. And then cosine at 62 is just a number, so we can divide that over the other side. And again, if you type that carefully into your calculator, 6 divided by the cosine, so again the trig button, press cosine at 62. Remember, I'm in radian mode, so I'm going to press degrees, and I'll get that exact same answer. So it comes out to the same thing. So either way, we will end up with our 12.780. Go ahead and try the second triangle. Pause the video now and see what you get. Again, sine is an excellent opportunity here because opposite the 25 is x, the hypotenuse is 16, so we can set up that trig function, multiply our 16 over to the left, and then all we have to do again is go onto our calculator and type that in. So we can type in, again, 16, the sine of 25. So 16, press that trig button next to the 7, sine of 25, and again, degrees. Another way to get to degrees is to press Control and then our little book over here at the right. And again, there's another opportunity to find that degree marker. But if you hit enter, you'll find out 6.0 6.762, remember to round correctly, 6.762 will be our correct answer, equal to x for our side length. Now the last way in which we're going to use trig functions, at least for the first part of our homework here, is to solve an entire triangle. And the big thing there is, remember, you want to remember from geometry, capital letters represent vertices. So I need to find little side b here. So we'll start off doing that one. Then I'm also going to need to find, if this is angle C, I'm going to need to find little c because I don't know the hypotenuse. So we'll find that side. And lastly, notice that we're also missing an angle. So we also need to know what the measure of angle A will be. And we can use some basic geometry for that. So go ahead and try right now. Go ahead and set up some equations for B and for C, as they're similar to our previous examples. Alright, now that you've set those up, again, B is the opposite. So using our given information, use your best numbers. We know that 37 and 5, that's the adjacent, and B is the opposite, so we can use a tangent. So I solved the tangent equation over here and went ahead and found that B is 3.768. I also found out that cosine at 37, if I use those given numbers again, try not to reuse the rounded numbers. So I'm going to go back and use my 37 and my 5, but cosine will help me find the hypotenuse. So I solved for that here in the middle. And on the very right side, 180 degrees is the addition of 90 degrees, 37, and A. Remember, all the angles of a triangle add up to 180. Or on a right triangle, the two non-right angles are going to add up to 90. And if I subtract my 37 over, I end up with my 53 degrees. A great way to check your triangles, again, is some basic geometry. The shortest angle should be opposite the smallest side. This larger angle, or the middle angle, should be opposite the middle side, this 5. And lastly, the largest angle, 90 degrees, ends up opposite the hypotenuse, the largest side on your triangle. Good luck with your trigonometry, and I hope you have a great day.